Today, we're going to pull back the curtain on something called Material Requirements Planning, or MRP. This is really the engine at the heart of all SAP production planning. We're going to break down exactly how this system makes sure that a massive factory has every single part it needs, right when it needs it. So let's dive in and see how this thing actually works. I mean, just stop and think about it for a second. A modern bike has literally hundreds of parts coming from dozens of different suppliers. How on earth does a company make sure that every single frame, every wheel, every gear, and every tiny screw is ready to go without running out of stuff mid-production or having a warehouse that's just overflowing with parts they don't need yet? Well, the answer to that chaos is MRP. Now, to make all this feel a bit more real, we're going to follow a fictional company. Let's just call them the Bike Company. Their entire business really depends on solving this one huge puzzle. They need a system that can look at their customer orders and figure out with incredible precision what to make, what to buy, and exactly when to do it. And that system, for them, is MRP. So here's our game plan. First, we'll look at the two big philosophies when it comes to planning. Then, we're going to get into the real nitty-gritty of how the system calculates what you need. After that, we'll see how it makes that classic make versus buy decision and schedules everything. And to wrap it all up, we'll look at the actual actionable results that drive the entire factory floor. Okay, so the very first thing you need to get your head around is that not all parts are created equal, and so they're not planned the same way. SAP gives us two main strategies, or you could say two paths, for planning our materials: deterministic and consumption-based planning. Let's see what that actually means for our bike company. So on one hand, you've got deterministic planning. This is for the big, important stuff, the really high-value A parts, like those expensive bike frames. This type of planning is driven directly by actual customer orders and sales forecasts. On the other hand, you have consumption-based planning. This method is way simpler. It just looks at how many you've used in the past to decide when to reorder the less critical, low-value stuff, like nuts and screws. And inside that consumption-based world, one of the most popular methods is called reorder point planning. The idea here is actually super simple. You just set a minimum stock level. That's your reorder point. And the second your inventory dips below that magic number, the system automatically kicks off a reorder. Here's how it plays out for our bike company's screws. This system is just constantly watching the inventory level. The very second that the count drops below their reorder point of, say, 500 units, bam, an automatic procurement proposal gets created. It's a really efficient, hands-off way to manage all those common parts. All right, so that takes care of the simple stuff. But what about the really complex, high-value parts that are planned deterministically? Now we're going to get into the core of the MRP run itself and see how the system calculates exactly what you need. Everything kicks off with something called a BOM explosion. BOM, of course, stands for Bill of Materials. It's basically the recipe. The system takes a finished bike and digitally explodes it, breaking it down into every single piece: the frame, the handlebars, the wheels, and then it goes deeper, breaking the wheels down into rims, spokes, and tires, and on and on. This is how it first gets a picture of the total ingredients needed. So once the system knows what it needs, it has to figure out when. And it does this using a cool trick called backward scheduling. It starts with the end goal, the date the customer needs their bike, all the way on the right of the timeline. And it literally works its way backward in time, subtracting out time for shipping, for production, for planning, to figure out the absolute latest date everything has to start. Okay, this is a really, really important point. So the system has its shopping list of parts and a full schedule, but it doesn't just go out and blindly start ordering everything. The next, and you could argue the most important step, is to check what you've already got on hand. And the way it does that is with the net requirement calculation. It's pretty simple math, actually. The system takes your current warehouse stock, adds any shipments you already have on the way, and then it subtracts your safety stock and any other demand that's already spoken for. What's left over is the amount that's truly available for planning. And the logic here is super straightforward. If that final number is positive, hey, you're good, you've got enough. But if the result is negative, the system raises a red flag. It's found a shortage. And that shortage is the alarm bell, it's the trigger that tells the system it has to create a procurement proposal. So we have a shortage. But how much should the system order? That question is answered by something called the lot sizing procedure. And you have options here. You can tell the system to order the exact amount to cover the shortage, or maybe you always order in fixed quantities, like a full pallet. You can even tell it, hey, just lump everything I need for this week into one big weekly order. Okay, so we know what we need, when we need it, and how much to order. The next logical question for the system to ask itself is, okay, where are we getting this from? Are we going to make it, or are we going to buy it? And this whole make or buy decision comes down to a simple setting called the procurement type in the materials master data. It's just a code. E means we make it in-house, F means we buy it from an external supplier, and X means, well, it's flexible, giving the planner the choice. This one little field dictates the entire next part of the process. So for all the parts we make ourselves, the system does another one of those detailed scheduling calculations. It starts from the date the part needs to be finished, then it works backward, subtracting time for things like quality checks and putting it away, then it subtracts the actual time it takes to produce it, and that gives it the final production start date. It's a super precise step-by-step plan. But you might be wondering, what happens if that backward calculation ends up with a start date that's yesterday? Well, the system is smart enough to know that's impossible, so it automatically flips its logic. It switches to forward scheduling, starting from today's date and calculating the absolute earliest date it can be finished. This just ensures the plan is always realistic. Okay, we have followed the entire logic, from checking what we need, to calculating how much, to figuring out where to get it and when. Now, let's get to the whole point of this and look at the tangible, actionable results that come out of the entire MRP run. This right here is the payoff. The entire MRP run generates two main types of proposals. For the stuff we make, it creates something called a planned order. For the stuff we buy, it creates a purchase requisition. Now, these are still just plans. The really critical step is when a human planner reviews them and converts them into the real deal, production orders and purchase orders that actually kick off work on the factory floor and with suppliers. And that's the most important thing to remember here. These proposals, these planned orders and purchase requisitions, they are the starting gun. They are the digital signal that kicks off the entire physical process of buying materials and actually making things. The whole execution cycle starts right here. So, the plan is perfect. The system has created this flawless set of requests to get every single part we need. But a plan on a computer screen isn't a finished bike, right? So that brings us to the final question. How does the factory actually execute this plan? How do these digital requests get turned into a real physical bike ready for a customer?
Welcome to